And finally, our last setup, our last side is this back side of the part. Do setup, new setup. What do we want to do? Well, we want to flip it around because now we want to be modeling and machining on this face. So, stock, I'm going to do a fixed size box here because we don't actually care about all this detail that we've machined away because we're only working with the top part of the part. So 4.23 and 0.99 actually works. All I want to do, if I orient it on the back view, I should be able to see that we've got all of our extra stock at the top here. So before we start playing with that, let's actually flip our orientation. Sometimes you can click the arrows to do it. That works. It's now pointed up, but I want this point to be right here. So I'll show you how we do that. This is a great example of where we pick instead of a stock box point, I want a model point. And it happened to jump right to the point that I want. Remember, very important, we need to pick a model. I'll pick that. It still looks correct, but now our stock is wrong. But again, that's one reason why I wanted to do this first. So go back to stock, and now we'll change the height to 1 inch. It's actually 0.99 just to be technically correct. And it should be not centered, but offset from the top. Nope, offset from the bottom. That's correct. And if you guys remember from class, what will be happening is we'll be clamping right between this face and that face, and all of the extra material is left up here. We don't have the ability to actually use this face, this plane here, click OK, as Z0, but if you remember what we did was we measured where this is going to rest, which is this plane, which is the top of our vice jaw. And we set that as negative 0.375. So if you think about it, because this, I wish I could select it. Let's go back to model. Yeah, so if we select that plane face sits on top of our vice jaw. So that means the top of our vice jaw, in theory, is the exact same height as the bottom of this. And we know we want this to here to be 0.375. So if we found this on the CNC machine and we tell it where that's going to be is negative 0.375, it sets that at 0. And that jives exactly with having a 0 right there. I did remember one thing we forgot to do back in our old setup. Take a quick look at that is when we shear hogged this stuff, we wanted to go a little bit below the part. So let's right click this at edit and geometry, or sorry, heights. We'll say model bottom minus 0.05. That's going to drive that shear hog tool just a little bit past our edge, which will be nice when we come to clean it up here in a minute. And I'll do the same thing with the 2D contour cleanup. Let's go 20 thousandths below the part. Wouldn't have necessarily made a bad part if we didn't do that, but as you can see, we'll go back to our setup here. The first thing we're going to do is shear hog away the 4 corners. Because remember, we can't take the Superfly and run it across because it'll cause the material to bend away and damage the tool and probably the part. So I'll do 2D adaptive. I'll pick my shear hog. And under geometry, I just want to pick the outside profile of my part. And we'll click OK and see what we get. Okay, it looks okay, just the wrong bottom height. That's again probably my particular to my computer. Selection, maybe not actually, of that face. Looks good. I've just got to adjust the width of cut and depth of cut. We'll say 0.2 and 0.2. Okay, and that's okay if it's only cutting it in one depth of cut if we think the tool can handle that. Importantly, what it's going to do again is remove this side material. We can now do a 2D face, and with our Tool 47 face mill Superfly, we'll want to do it no more than say 0.06 depth of cut, at least for the 440s. It's going to deck that part off, and now this is actually what's really cool is we can click on the first setup that we had today and the second one. So I've got those two selected. If we simulate and we click on this face, it rapids through everything up to there. Actually, I'll back that up here in a second and show you how useful that really is. But you can see now we're just decking off the last of that material. If instead what I do is show you guys, we just wrap it up to here, you can see what we've got left. If you guys remember holding the part when it looked like this, we've got to get rid of these areas right here. So also let us just take a look at what that cut looks like. Is it too deep? Oops, click on this one, click play. And you guys remember, no, the Shearhawk can handle that sort of a cut, no problem at all. We did our facing. We want to rough out this 3D contour here, so I'm going to go 3D adaptive clearing with tool 31, 1/4 inch regular end mill. Because remember, ball end mills are kind of special. We want to treat them, delicately, so we'll do the worst of this work with the 1/4 inch tool. This is one of those quirky, complicated things in Fusion 360. Geometry, change it to machining boundary selection. And I want to select this face. I wish I could click on the face. I can't. The way we select just this little area here, we click on the outside profile once and let up. We have this blue line. We're going to click and hold on this blue line and let up. This new thing has popped up here. You see that? All we need to do is move our mouse over to right here. That's the one I want. This would work, but I'd rather have this one. Click on it once, like so, and click this green plus to accept the contour. Now it's relegated or limited our tool to that little section. Under passes, the fine step down will say 25 thou. It's, some small numbers okay, like 25, 30 thou. And let's just leave 5 thousandths of radial and axial. We don't want to leave too much at all. Click OK. And what you can see is it's doing some step downs, exactly what we want. A quick simulation would show, again, it helps if you simulate both because it's going to give you a more accurate view of the whole part. Jump forward to that. Oh, good. I'm glad we did that because it's going to remind me that we don't need to start helical ramping all the way up there. That's so high. So I like that, except the ramp started too high. See how it's stair-stepping that majority of that material out? Again, makes it easier on our ball end mill. Let's lower the red curly Q by going into linking, ramp, and we can change the ramp clearance height to it is 0.1, that's okay. So what that tells me, if we think about it, well, 0.1, it looks like it's going, to me at least, it looks like it's going way more than 0.1. So if we look, what it's doing is it's thinking that the top height is our stock top. And in reality, the top height now is this plane because we've machined everything down to it. So sure enough, if we click OK and take a look, the red should be much lower now. So now it's starting 0.1 above that plane. Perfect. 3D parallel, and let's pick that tool 40. I'm not sure if I have it on this computer. Yep, I do. Good. Same thing with the geometry. Click once to select the outside profile. Click on that blue line. Click here and click plus. That limits that selection to here. On passes, we'll switch it to say a 15 thou step over. Click OK. Let's see what we get. That looks good. A couple things that we can change. I like to do an additional offset of say 0.05. It's going to push the tool a little bit past all of the edges, which can sometimes help with the cleanup and how it looks. And then one of the fun things that we did was we can create sort of a fake knurl by doing our passes at 45 degrees on one. So you see that puts it at an angle, and I'll duplicate it. Oops, I duplicated it twice, sorry. Duplicate it once and change this one to negative 45. So this is really cool. If we take a look, we've got one adaptive that's one direction, the next, or parallel that's one direction, the next parallel is the other. Awesome. For those of you that may have lost your name like I did, it's on a sketch plane. And any time in Fusion you get frustrated because you don't see stuff, go ahead and poke through the light bulbs. So I'm going to take my part, expand the down arrow to see everything I've got. And sure enough, I think if we go down to sketch 6, the last one, and we toggle on and off, we see there was our name. That's a 2D trace. We're going to change to tool 90. Do I have tool 90 on this computer? Not sure I do. I'll just pick tool 25 for now. We did tool 90 on our training computers. And all I got to do is click my text, and we need to tell it to go into that material a little, so we'll do an axial offset of -0.01. Click OK, and we get our toolpath. That's it, folks. Again, please always feel free to shoot us an email or post a question if you've got some additional follow-up or needs you've got. We appreciate you taking our training class. We hope it helped. Take care. See you soon, folks.